Good day, ladies and gentlemen, and let us jump into Chem. We're talking about heat and temperature, right? And last time we kind of gave some definitions here. We said, hey, what is temp? Well, temp is a measure of average kinetic energy, and that average kinetic energy we all know is equal to 1/2 mv squared, where v is equal to the velocity of the particles. So that temperature really is what? A measure of the velocity of the particles. And we have two scales of temp that we talk about. We talk about Celsius and Kelvin, and that the Celsius is based on the freezing point and boiling point of water, and that is 0 degrees Celsius is the freezing point of water, and 100 degrees Celsius is the boiling point of water, and that Kelvin is really based upon the motion of particles, and specifically that it is based on absolute zero. At absolute zero, it means my average kinetic energy equals 0, which means the velocity of my particles is 0, meaning there is absolutely no movement of particles. Okay, so there's no movement of particles at absolute 0, and so Kelvin is based on that. And there's a relationship between these, and that is Kelvin is equal to degrees Celsius plus 273.15, and that you can convert between each of these. And one important thing we said is, hey, a delta T in Celsius is equal to a delta T in Kelvin, that the size of the degree of 1 degree Celsius, the size of it is exactly the same size as 1 degree Kelvin. So when we're looking at delta T's, it really doesn't matter if we're talking about Kelvin or Celsius. Good. Now we also talked about heat. And we said, hey, what is heat? Well, we said heat is the transfer of energy between bodies of different temp. So it's the difference of temperature that allows heat to occur, right? It allows heat to exist. Good. Difference of temp. We said that it is denoted by Q, that its unit is for us typically the joule or the kilojoule, and that is a big J. Good. What else? Transfer of, oh yes, and it always goes from, heat always is transferred from hot to cold, and it never goes from cold to hot. And then we started talking about some calculations that we could do with heat, and that we have a big equation, the most important equation, right? Q is equal to mc sub p delta T, where this is the mass of my body, this is the specific heat of the body, and this is the delta T, change in temp of the body. The specific heat is what? It is the amount of heat required to raise 1 gram of the substance 1 degree Celsius or 1 degree Kelvin, right? And that is usually in joules per gram Kelvin or joules in gram Celsius, one of those two. And that delta T, zoink, delta T means what? My final temperature minus my initial temperature. Now, that doesn't always have to be positive. It can be negative. It all depends. I take my final temperature, subtract my initial temperature, and that's my delta T. Got it? Woo! That's what we did last time. Now, let's do a couple more questions, and then we are in great shape. Here we go. Consider a 10 gram block of iron initially at 10 degrees. Okay, what is the final temp after it has absorbed 175 joules? Good. Well, we're going to do what? Q equals mc sub p delta T, and we'll start plugging in numbers. It says it has absorbed. That means that it's a positive number. 175 joules is equal to 10.0 grams. C sub p, 0.449. Always watch your units, joules per gram Kelvin, and then I get a delta T. So I can solve for delta T, And let's use my magic TI 30XA 175 divided by 10 divided by 0.449. It looks to me like I get a 38 point, how many sig figs? 333. 38.97. We'll carry that one extra sig fig for a sec, right? That is my delta T, but I don't want delta T. It says, what is the final temp? Okay, and delta T is equal to what? T final minus T initial. This is my delta T. And since, what do we have here? Is it in Kelvin? It's in Celsius. Good. Remember, a delta T in Kelvin equals a delta T in Celsius. So this 38.97 equals 38.97 Celsius. Why? Because it is a delta T. Good. So now let's put this in. Substitute. 38.97 degrees Celsius equals TF minus my initial temperature, 10.0. Good. So that looks to me like what? 28.97 degrees Celsius. I can only be significant to the tenths. So this becomes 29.0 degrees Celsius is my delta T. What is my delta T in Celsius and in Kelvin? Hey, they're the same, right? They are both 38.97 degrees Celsius, 38.97 Kelvin, because a delta T is the same if it's in Kelvin or Celsius. A delta T, not just T, but a delta T. Cool. All right, you guys do this one. Bring me back when you're ready. Well, I'm going to do the same thing, right? Consider blah, blah, blah. I have this here. What is it? That looks like heat to me. I have a temperature. I have a C sub P, specific heat. So Q equals M, C sub P, delta T. What's my Q? 25000. Now remember, always watch your units. Joules. Is equal to mass. What's my mass? What would be the 352 grams. And what else do I know? I have a 4.18 joules per gram Kelvin. First thing I have to do is calculate my delta T. So my delta T is equal to 25000 divided by 352 divided by 4.18, and I get 16.99. It looks like I have two sigs here. So that means these two guys are not significant. Cool, that's my delta T, and my delta T is equal to T final minus T initial. What do we have here? What would be the final temp? So I'm looking for TF, and what is given? Would be the final temp. Oh, the initial temp has to be, I start with 352 grams of water at 298. So that would mean I have 16.99, and this is, we're looking at Kelvin this time because it's a delta T. I can make that change, right? TF minus 298. Oops, I think I made a mistake last time, didn't I? Yes, I did. Oink. Here, we'll fix this and we'll go back and fix my mistake. So I have 16.99, add 298 plus 298 to both sides, and what do I get? I get 315 Kelvin. Whoops, good. Remember, I have to add 298 to both sides, plus 298 to both sides. What did I do last time? Unks, what did I do? I didn't add this. I subtracted it. That's wrong, wrong, wrong. Okay, so let's fix it. Add 10 degrees to both sides, and my answer should be, we can use the magic eraser here, and the answer should be what? 30, nope, not 30, how about 48.97, and when I go to my tenths, that's going to be 49.0 degrees Celsius. Woohoo! Wow, good thing I had to do another one to get that right. All right, sorry for that mistake. Now it is fixed. Cool. Moving on. Okay, I have a tin block of iron initially at 3. It is then placed in 50 grams of cold water. Eventually, the temperature of the iron drops to, ooh, mama, what do we do here? Okay, this is a special case. Are you ready? Let's make sure I have time to do this. Yes, we have time. All right, what we need to do here is take a look at a picture. here's what I have going on here. I have water. And what do we know about this water? I have 50.5 grams of this water. And that's all I really know about my water. What I do know about my water is from our last question is that my C sub P for my water is equal to 4.18 joules per gram Kelvin. Okay, and that I know from right here. Got it? What else do I know? I'm going to take a block of iron and I'm going to drop it in here. And what do I know about this iron? Well, I know that it's 10 grams, and it's initially, it is a Ti equal to 390 Kelvin. And I do know it's C sub P. How do I know it's C sub P? Well, from our earlier question, the specific heat of iron is 0.449. Okay, so I know that this is 0.449 joules per gram Kelvin, and that's for Fe. Got it? Good. And what else do I know? I know that eventually the temp of the iron drops to 281. So what does that mean? I know that the TF for my iron is 281. Okay, now here's the one little trick you have to understand. We are going to assume, since the iron is in water, that all the heat lost by the iron goes to the water. So we are going to say that QFE equals QH2O, except for what? One of them is losing and one of them is gaining, so that means there's a negative on one. So the Q of Fe is equal to negative Q for water. That's the one thing we have to understand when we're doing this. The second thing is the final temperature. We're going to assume that this block and this water is in what's called thermal equilibrium. And what does thermal equilibrium mean? That means they will reach the same temp eventually. And so what does eventually mean? It means TF. It means the TF for my iron will equal the TF for my H2O. Okay? So those are the two things we have to know when we're doing this kind of question. All right? So first thing we want to know is, what does it say? How much heat did the iron lose? Okay? So QFE is equal to MFE C sub P Fe delta T Fe, right? Let me get rid of this stuff for a second. Oh, I hate to do that, but we'll rewrite it. Good. So what's my M? My M is 10.0 grams of iron. We want to just, this all have to do with iron right now. C sub P of iron, 0.4444 what, 9? It looks like a G. 9 of joules per gram Kelvin. And then what's the delta T? My delta T, what's my initial temperature, or what's my final temperature? Remember, it's always TF minus TI. So it's 281K minus 290K. 290, 390K. 3.0. 390K? Yeah, sure looks like 390 to me. 390K. Good. So then, what do I get out of this? Let's use the magic calculator. I'm going to take 281 minus, yikes, not plus, equals, yikes, 281 minus 390, and I get a negative 109 for my delta T times 10.0 times 0.449. Good, so let's run that out. Times 10 times 0.449, and I get a negative equals a negative 489 point, I think we can carry one more sig fig here, or one more fig, and this is what? Grams cancel, Kelvin cancels, and I'm left with joules. All right, so my answer to the first one, how much heat did the iron lose? And the answer is 489, and with no sig, I mean, there's only 3 sig figs here, sorry. 489 is how much it lost. The negative implies that it is lost. So whenever you see a negative heat, that means it is lost. So if they said, what was the heat change, you'd write down negative 489. If they how much heat was lost, then you just could write down the 489 joules. Got it? Where did the heat go? It went from my iron into my water. So that means what? It means Q of iron is equal to negative Q of H2O, which means that is equal to Q of iron is negative 489, so that means that the Q H2O is going to be positive 489.4 joules. Got it? Good. Now, what is the delta T? Hey, we can work that out. For water, so we have to do everything for water. Q H2O is equal to M, what? H2O, C sub P, H2O, delta T, H2O. Cool. So what's Q for water? We already figured that out right here. It is a positive 489.4, where the 4 is not significant. What's my mass of water? Let's see. I have 50.5 grams of water. 50.5 grams of water. What is the specific heat? 1.48 joules per gram Kelvin. I have that one memorized. Delta T of water. So let's solve for my delta T H2O. Okay, here we go. I'm going to take 489.4, divide it by 50.5, divide it by 4.18. And what do I get? I get, how about a 2.318? 2.318 Kelvin. Good. What was the final temp of the water? Well, what was my delta T is equal to TF minus TI. Let's hope I can do my math right this time. 2.318 Kelvin is equal to, and what's my initial? The temp drops 2. Says the temperature of the iron drops to, oh, so that means what? This is my final TF. That's my final of my iron. But what did we say about thermal equilibrium? That's also my TF for my H2O. So both of them ended up at 281. So that means this is 281 K minus TI. So what is TI? Let's see if I can do this right this time. I'm going to take, this has to go over on this side, and this has to come over on this side, and that means I'm going to subtract that number from 281, and I get 278.6, but I can only be significant here to the units, so 279. Okay, cool. 279 Kelvin. So that means I started off with water at 279. I drop a hot piece of iron in it, and what do I expect to happen when I drop hot stuff in cool water? I expect my cool water to do what? Increase in temp. So it starts at 279 and it goes to 281. Oops. Sorry, folks. That answer goes here. What was the final temp? The final temp was what? We said the final temp of my water equals the final temp of my iron. Why? Because of thermal equilibrium. That eventually both those temps will have the same final. Sorry, I answered these out of order. What was the initial temp? There we go. My 279. Whew. Okay, I think you guys can follow that out. It's a little bit crazy the way I answered it, but I think you guys can do it. Here, give this one a try. Bring me back when you're ready. All right. What always helps me to do these things is I want to see a picture. I have a hard time without having the picture here. A 15-gram block of iron, so I'm going to drop a block of iron in here. It's going to be 15 grams. So here's my iron stuff. And what? A block of iron at 150. Okay, so that means that's my initial temp equals 150 Celsius. For my last question, I know that the C sub P of iron is 0.44 joules per gram Kelvin. It says what? My water says is dropped into cold water. So my initial temp of my water is equal to 0.0 Celsius. The final temp of the water, TF, is equal to 15 degrees Celsius. But if that's my TF of water, what does that mean? It means all of this is 15 degrees Celsius, meaning what? That means my TF of my iron is also 15 degrees Celsius. Okay, good. How much heat was released by the iron? All right, here we go. Q equals MC sub P delta T. What's my M for iron? 15.00 grams. The 0.449 joules per gram Kelvin for my C sub P of my iron. And then my delta T. Delta T, what is my TF? Well, the final temp is, we said 15.0 degrees Celsius. What's my initial? 150 degrees Celsius. All right. What do we get here? So I have 15 minus 150, which is a negative 135, times 0.449 times 15 equals a negative 909. How many sig figs? 3 here and 2 here, actually, right? No. We're fine. 3 there, too. So I get 0.909.2. What is this? Yoink, 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 yoink. Joules, which when we look at sig figs is negative 909 joules. And what does the negative mean? It means it is how much was released. So you could simply answer this as 909 joules. Okay, great. What's the mass now of the water? Well, we go back to this. Q of my iron equals negative Q of my H2O. Why do we say that? All the energy lost, all the heat lost by my iron goes into the water. So if I have a negative 909.0 on 0.2 joules for iron, then what is the Q of my water? Well, negative what? 909.2 joules. So this is my Q water. Good. So I have 909.2 joules, which is Q water, M water, C sub P water. What's C sub P? 4.18 joules per gram Kelvin for water. And what's my TF minus TI? What's my TF? My TF is 15.0. What is my TI? 0.0 degrees Celsius. Good, and that must be before my water. I mean, my water is all liquid at this time when we say that. Cold water, not ice, so somehow it's already been converted all to liquid water. Good. And what do we get? Solve for M. Divided by 4.18, divided by 15, and I get 14.5 grams of H2O. There you go. Let's see if that works. Let's try it in reverse. 14.5 times 4.18 times 15, and I get 909.15. Yeah, there we go. That's my answer. Woo! Those are pretty cool. I love those kinds of questions. Great. Okay, that'll be it. Next time, we will get into phase changes. Got it? See ya.